In this video, we're going to work on the focused exercise from 2.7. We'll need to use StatCrunch, so you'll need to open your MyStatLab account. Once the dashboard is displayed, we're going to choose the StatCrunch option. We're going to use the data sets from our textbook. Now that we've opened StatCrunch, we can use the first column to enter our measurements. So this might take you a few minutes to enter them. Now that we have our data entered in column 1, we're going to find the mean, median, and mode for these sample ages of a class. To use StatCrunch to find the mean, we're going to the Stat tab, Summary Stats, Columns, and our data is in Variable 1 column, so we need to select that. And you'll see under the word statistics there are many options listed in this box, and there is a bar to drag down to choose from other options. So we need the mean, the median, and the mode. So I'm first going to click on the mean. Then you'll need to hold down the Control key of your keyboard and at the same time click median and mode. So I'll need to drag this bar down to find median and mode. There's median, and mode is the last option. And you'll see that mean, median, and mode are now in the selection box to the right. So if you need to try that again, you can always go back and delete these and select them again. I'm going to compute, and in this summary box, it shows me now for column var1, which is our first variable, the mean is 21.7, the median is 21.5, and the mode says no unique. If you get no unique, I would go back to the data just to make sure, because it's only going to list a mode if one number appears more times than another. But if more than one measurement appears at the same number of times, it's not going to detect that. So we can see 18 is only once, 19 is once, 20 appears 1, 2, 3, 4, 5 times. 21 only appears 3, 22 appears twice, 23 appears 1, 2, 3, 4, 5 times. And so far, 20 and 23 both appear 5 times. 24, 25, and 26 appear only once. The number 20 and the number 23 are both the mode because they both appear 5 times, and that is the most of any measurement in our data set. So we're going to go to the sheet 2.7. Question 1 wants us to find the mean, median, and mode of the following sample ages of a class. So we found those values. Move that over a little bit so we'll be able to see both pages at the same time. So for number 1, the mean was equal to 21.7, the median is equal to 21.5, and we found that the mode was 20 and 23. For question 2, we're going to create a frequency histogram for the data. For the frequency histogram, we need to have our frequency axis, and we'll need another line for the ages. If we look back at the data for the ages, it is already in ascending order from 18 to 26. We only need to account for each age one time. So I'll start with 18 and number to 26. And since this is a frequency histogram, frequency means the count. So 18 appears only once. Our highest was 20 and 23 appearing 5 times. So the largest or the highest we need to go for frequency is 5. And now we're ready to draw the bars. So 18 appears only 1 time. 19 also appears 1 time. 20 appears 5 times. 21 appears 3 times. 22 appears twice. 23 appears 5 times. 24 appears only once, as do 25 and 26. So we can add 3 more bars at a height of 1. And now we have our histogram complete. Again, you could write down the frequencies above each of the bars if you like that kind of detail. You can see that each of these occurs once, 22 occurred twice, 3 times for 21, and 5 times for ages 20 and 23. For part 3, we're going to label the measures of central tendency on the histogram. The measures of central tendency are the mean, median, and mode. So our mean is 21.7. The median is 21.5, and the mode occurs at 20 and 23. For number 4, we're going to calculate the range and standard deviation. We can use StatCrunch to calculate the range and standard deviation. So we're going to go back to the first column, choose the Stat tab, choose Summary Stats for column. The only column we have is the first variable, and we're going to the statistics box, and what we're looking for here is the range and standard deviation. Since I don't see range yet, but here's standard deviation, so I can choose standard deviation and then hold down the control key and at the same time pull down this bar until you find range, select range. And now I have both standard deviation and range selected. Compute, and you can click on the box and drag it so it's not covering your other information. So we have a standard deviation of about 2.05 and the range is 8. So our range is 8, standard deviation is about 2.05. Remember, the range is found by just taking the largest value of 26 minus the smallest value of 18, and that's how we get a range of 8. Question 5 says, suppose Tanya is 24 years old. What is her sample z-score? So we have to recall the z-score formula in order to answer this question. We're going to find the x value minus the mean and divide by the standard deviation. So our z-score is going to be equal to Tanya's age, 24 years old, that is our x value, minus x bar. The mean we found was 21.7, and that will be divided by 2.05. And this z-score comes out to 1.12. Since it's a positive number, it tells us that this z-score falls between 1 and 2 standard deviations to the right of the mean. Question 6 is asking about what is the skew of the sampling distribution. We can compare the mean and the median. So if we think back to mean versus median, our mean is 21.7 and the median is 21.5. Well, 21.7 is just slightly larger than 21.5. So that means we do have a mound shape that is skewed to the right. So when the mean is larger than the median is falling to the right of the median, and that is what is skewing the data to the right. Now we could imagine a smooth curve drawn over this histogram, and that's where we're getting the mound shape from. And since the mean is to the right of the median, that means that it is larger than the median. And that is pulling the data towards the right, making a longer tail on the right side of our mound. So our data is mound shaped and skewed right. For number 7, we're going to calculate what percent of the data falls within 1, 2, and 3 standard deviations of the mean. So in order to do this, we need to start with the mean, which is 21.7, and we would have to add a standard deviation, which was 2.05, and that brings us to 23.75 to be with 1 standard deviation to the right. If we add 2.05 again, we'll be at 25.8, and adding 2.05 again, we'll be at 27.85. We'll also need to calculate what values are found to the left of the mean. So this is where we're going to start with the mean of 21.7 and subtract standard deviation. So we'll be at 19.65. Take away another standard deviation, and we will be at 17.6. And once again, to be 3 standard deviations to the left of the mean, we're going to subtract 2.05, and this time we're going to be at 15.55. Now we have all of our measurements describing the ages from 1 to 3 standard deviations from the mean. Now that we have all of the ages within 1 to 3 standard deviations, we can perform the calculations now to find what percent of the data falls within this first standard deviation. So we have a low of 19.65 and a high of 23.75. These are also known as intervals from minimum, maximum. So it might help to write these out. Our first interval is 19.65 to 23.75. Second interval is going to be a minimum of 17.6 to a maximum of 25.8. And the last interval has a minimum of 15.55 and a maximum of 27.85. So now we can use these intervals and look back at the ages. How many ages in our data set fall between 19.65 and 23.75? So we're going to make a count. Looking back at the data, our first entry is 18. 18 is not a number falling in that range. It is too small. 19 is also too small because our interval starts at 19.65, so we can't use 19. 20, that does fall between our minimum and maximum, so I know that we need 20. So every number that is 20 we're going to include. 21, that can be included because 21 does fall within that interval, so all of the 21 entries. 22 is also included. 23 is going to be included for that first interval. However, 24 is too high because 24 is greater than 23.75. So that cannot be included in the count. So we just count how many numbers that were circled. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 numbers out of the 20. So X bar within one standard deviation is 15 out of 20, which is 0.75. To be within 2 standard deviations, the age has to be at least 17.6 and no greater than 25.8. So we already have 15 of our numbers included. So are there any others that could be included? Is 18 a number that falls between 17.6 and 25.8? That is. 19 would also be included. And at the end, is 24 included? It is. 25, that would also be included. But 26 is too large. So we've now included 19 of the 20 numbers. So to make our calculation, 19 out of 20 is 0.95. And finally, to be within 3 standard deviations of the mean, the ages have to be at least 15.55 and less or equal to 27.85. So the only measurement we haven't included yet is 26, and 26 does fall between that minimum and maximum. So now all 20 data points out of 20, or 1. So if we convert these to percentage, 0.75 times 100 would give us 75% of the data falls within 1 standard deviation. 0.95 times 100 means 95% of the data falls within 1 standard deviation. And finally, 1 times 100 would mean 100% of the data falls within 3 standard deviations of the mean. So now that we have the percentages, we can determine the answer to number 8. Does it make sense to draw a distribution curve for the data? So the way we would know that it would make sense is to check out these percentages. The empirical rule says 95% of the data needs to fall there, and we have exactly 95. So the empirical rule would be a good predictor for our data set. And we also meet the criterion for 3 standard deviations with empirical rule. The empirical rule states that 99.7% of the data should fall within 3 standard deviations, and we have met that and exceeded it with 100% of our data. So it does make sense to draw the distribution curve. So that's what we'll do next. So we have our curve, and we know that at the center, or that highest peak, we're going to have the mean. The mean is 21.7, so we're going to label 21.7, and we'll put all of our standard deviation bars. And now we need to label each bar. We know that the standard deviation is 2.05, and we came up with all of our calculations already. So we know that to the left of the mean is 19.65, and to the right 23.75, and then 2 standard deviations, we have our values, and 3. So let's label all of the bars. Now that we have all of our labels, we can go back and locate the median. The median was at 21.5. And notice the mean is already labeled. Again, the mean falls to the right of the median because the mean is larger than the median. So we should come to the same conclusion that we have our data skewed to the right. And finally, for question 9, we're going to shade the area on the distribution which represents Tanya's age. So to find Tanya's age, she's 24 years old. So 24 would fall between 23.75 and 25.8. Now that we've located Tanya's age under the distribution curve, we can see that her age of 24 fits within 2 standard deviations of the mean. And that's where we have about 95% of the ages of people in the class.